On-sample tests of hypothesis. Chapter 10. Learning Objectives. LO10-1 Define a hypothesis. LO10-2 Explain the process of testing a hypothesis. LO10-3 Apply the 6-step procedure for testing a hypothesis. LO10-4 Distinguish between a one-tailed and a two-tailed test of hypothesis. LO10-5 Conduct a test of a hypothesis about a population mean. LO10-6 Compute and interpret a p-value. LO10-7 Use a t-statistic to test a hypothesis. LO10-8 Compute the probability of a type 2 error. LO10-1 Define a hypothesis. Examples. Pay is related to performance. People who are paid more perform better. Consumers prefer Coke over all other cola drinks. Billboard advertising is more effective than advertising in paper-based media. Consumer confidence in the economy is increasing. Hypothesis testing. LO10-2 Explain the process of testing a hypothesis. Hypothesis testing, a procedure based on sample evidence and probability theory to determine whether the hypothesis is a reasonable statement. Step 1. State the null and the alternate hypothesis. LO10-2. Step 1. State the null and the alternate hypothesis. Null hypothesis: a statement about the value of a population parameter developed for the purpose of testing numerical evidence. It is represented by H0. Alternate hypothesis: a statement that is accepted if the sample data provide sufficient evidence that the null hypothesis is false. It is represented by H1. Step 2. State a level of significance, errors in hypothesis testing. The significance level of a test. Defined as the probability of rejecting the null hypothesis when it is actually true. This is denoted by the Greek letter dot. Also known as type I error. We select this probability prior to collecting data and testing the hypothesis. A typical value of is 0.05. Step 2. State a level of significance, errors in hypothesis testing. Another possible error. The probability of not rejecting the null hypothesis when it is actually false. This is denoted by the Greek letter beta. Also known as type 2 error. We cannot select this probability. It is related to the choice of the sample size, and the data collected. Step 2. State a level of significance, errors in hypothesis testing. Step 3. Identify the test statistic. LO10-2. Step 3. Identify the test statistic. Test statistic: a value, determined from sample information, used to determine whether to fail to reject or reject the null hypothesis. To test hypotheses about population means we use the Z or T statistic. Step 4. Formulate a decision rule, one-tail versus two-tail tests. LO10-2. Step 4. Formulate a decision rule, one-tail versus two-tail tests. Critical value based on the selected level of significance. The critical value is the dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. If the test statistic is greater than or less than the critical value, in the region of rejection, then reject the null hypothesis. Step 5. Take a sample, arrive at a decision. LO10-2. Step 5. Take a sample, arrive at a decision. Identify an unbiased sample. Collect the data on the relevant variables. Calculate test statistics. Compare the test statistic to the critical value. Make a decision, i.e., reject or fail to reject the null hypothesis. Step 6. Interpret the result. LO10-2. Step 6. Interpret the result. What does the decision to reject or fail to reject the null hypothesis mean in the context of the study? Examples. Based on the data, there is no evidence to support the hypothesis that pay is related to performance. Based on the data, there is evidence that billboard advertising is more effective than paper-based media advertising. LO 10.5 Conduct a test of a hypothesis about a population mean. Hypothesis test of a population mean, known population standard deviation. Example. Jamestown Steel Company manufactures and assembles desks and other office equipment. The weekly production of the Model A325 desk at the Fredonia plant follows the normal probability distribution with a mean of 200 and a standard deviation of 16. Recently, new production methods have been introduced and new employees hired. The VP of Manufacturing would like to investigate whether there has been a change in the weekly production of the Model A325 desk. How to set up a hypothesis test. LO 10.3 LO 10.5 How to set up a hypothesis test. In actual practice, the status quo is set up as H0. If the claim is boastful, the claim is set up as H1. We apply the Missouri rule, show me. Remember, H1 has the burden of proof. In problem solving, look for keywords and convert them into symbols. Some keywords include improved, better than, as effective as, different from, has changed, etc. Keywords. Inequality. Symbol. Part of. Larger, or more, than. Greater than. H1. Smaller, or less, than. Less than. No more than. H0. At least. Greater than or equal to. Has increased. Is there difference? Does not equal. Has not changed. Equals. Has improved, is better than, is more effective. See keywords. Hypothesis setups for testing a mean. LO 10.5 LO 10.3 Hypothesis setups for testing a mean. Important things to remember about H0 and H1. LO 10.5 Important things to remember about H0 and H1. H0 is the null hypothesis, H1 is the alternate hypothesis. H0 and H1 are mutually exclusive and collectively exhaustive. H0 is always presumed to be true. H1 has the burden of proof. A random sample, n, is used to reject H0. If we conclude do not reject H0, this does not necessarily mean that the null hypothesis is true, it only suggests that there is not sufficient evidence to reject H0. Rejecting the null hypothesis suggests that the alternative hypothesis may be true given the probability of type I error. Equality is always part of H0, for example equals, greater than or equal to, less than or equal to. Inequality is always part of H1, for example does not equal, less than greater than. LO 10.3 LO 10.3 Hypothesis test of a population mean, known population standard deviation. Example. Step 1, state the null and alternate hypotheses. H0 equals 200. H1 does not equal 200. Note, the keyword in the problem has changed. Step 2, select the level of significance. Alpha equals 0.01 as stated in the problem. LO 10.3 LO 10.3 Hypothesis test of a population mean, known population standard deviation. Example. Step 3, select the test statistic. Use z-distribution since sigma is known. LO 10.3 LO 10.3 Hypothesis test of a population mean, known population standard deviation. Example. Step 4, formulate the decision rule. Reject H0 if vertical bar z vertical bar greater than z/2. Step 5, make a decision and interpret the result. H0 is not rejected because 1.55 does not fall in the rejection region. Step 6, interpret the result. We conclude that the population mean is not different from 200, so we would report to the Vice President of Manufacturing that the sample evidence does not show that the production rate at the plant has changed from 200 per week. LO 10-4 distinguish between a one-tailed and a two-tailed test of hypothesis. Hypothesis test of a population mean, known population standard deviation, one-tail example. Suppose in the previous problem the Vice President wants to know whether there has been an increase in the number of units assembled. To put it another way, can we conclude, because of the improved production methods, that the mean number of desks assembled in the last 50 weeks was more than 200? Recall, sigma equals 16, n equals 200, alpha equals .01. One-tailed test versus two-tailed test. LO 10-4. One-tailed test versus two-tailed test. LO 10-4. Testing for a population mean, known population standard deviation, one-tail example. Step 1, state the null hypothesis and the alternate hypothesis. H0, less than or equal to 200. H1, greater than 200. Note, the keyword in the problem and inquiries. Step 2, select the level of significance. Alpha equals 0.01 as stated in the problem. Step 3, select the test statistic. Use z-distribution since sigma is known. LO 10-4. Testing for a population mean, known population standard deviation, one-tail example. Step 4, formulate the decision rule. Reject H0 if z greater than z. Step 5, make a decision. Because 1.55 does not fall in the rejection region, H0 is not rejected. Step 6, interpret the result. Based on the evidence, we cannot conclude that the average number of desks assembled increased in the last 50 weeks. P-value in hypothesis testing. LO 10-6 compute and interpret a p-value. P-value in hypothesis testing. A p-value is the probability of observing a sample value as extreme as, or more extreme than, the value observed, the test statistic, given that the null hypothesis is true. In testing a hypothesis, we can also compare the p-value to the significance level. Decision rule using the p-value. Reject H0 if p-value less than significance level. P-value in hypothesis testing, example. LO 10-6. P-value in hypothesis testing, example. Recall the last problem where the hypothesis and decision rules were set up as H0, less than or equal to 200. H1, greater than 200. Reject H0 if z greater than z. Where z equals 1.55 and z equals 2.33. Reject H0 if p-value less than 0.0606 is not less than 0.01. Conclude, fail to reject H0. What does it mean when the p-value less than question mark? LO 10-6. What does it mean when the p-value less than question mark? If p-value equals .10, we have some evidence that H0 is not true. If p-value equals .05, we have strong evidence that H0 is not true. If p-value equals .01, we have very strong evidence that H0 is not true. If p-value equals .001, we have extremely strong evidence that H0 is not true. Testing for the population mean, population standard deviation unknown. LO10-7 Use a t-statistic to test a hypothesis. Testing for the population mean, population standard deviation unknown. When the population standard deviation, sigma, is unknown, the sample standard deviation, s, is used in its place. The t-distribution is used as the test statistic, which is computed using the formula. LO10-7. Testing for the population mean, population standard deviation unknown. Example: the McFarland Insurance Company Claims Department reports the mean cost to process a claim is $60. An industry comparison showed this amount to be larger than most other insurance companies, so the company instituted cost-cutting measures. To evaluate the effect of the cost-cutting measures, the supervisor of the claims department selected a random sample of 26 claims processed last month. The sample information is reported below. At the 0.01 significance level, is it reasonable to conclude that a claim is now less than $60? LO10-7. Testing for a population mean, population standard deviation unknown. Example: Step 1, state the null hypothesis and the alternate hypothesis. H0, greater than or equal to $60. H1, less than $60. Note, the keyword in the problem is now less than. Step 2, select the level of significance. Alpha equals 0.01 as stated in the problem. Step 3, select the test statistic. Since sigma is unknown, use a t-distribution with n1, 26 to 1 equals 25. Degrees of freedom. T-distribution table, portion. LO10-7. T-distribution table, portion. LO10-7. Testing for a population mean, population standard deviation unknown. Example: Step 4, formulate the decision rule. Reject H0 if t less than t, n1. Step 5, make a decision. Because -1.818 does not fall in the rejection region, H0 is not rejected at the 0.01 significance level. Step 6, interpret the result. We have not demonstrated that the cost-cutting measures reduced the mean cost per claim to less than $60. The difference of $3.58, $56.42, $60, between the sample mean and the population mean could be due to sampling error. LO10-7. Testing for a population mean, population standard deviation unknown. Example: the current rate for producing 5 amp fuses at Neri Electric Company is $250 per hour. A new machine has been purchased and installed that, according to the supplier, will increase the production rate. A sample of 10 randomly selected hours from last month revealed the mean hourly production on the new machine was 256 units, with a sample standard deviation of 6 per hour. At the 0.05 significance level, can Neri conclude that the new machine is faster? LO10-7. Testing for a population mean, population standard deviation unknown. Example: Step 1, state the null and the alternate hypothesis. H0, mu less than or equal to 250 H1, mu greater than 250. Step 2, select the level of significance. It is 0.05. Step 3, select the test statistic. The population standard deviation is not known. Use the t-distribution with n1, 10 to 1 equals 9, degrees of freedom. LO10-7. Testing for a population mean, population standard deviation unknown. Example: Step 4, state the decision rule. There are 10 to 1 equals 9 degrees of freedom. The null hypothesis is rejected if t greater than 1.833. Step 5, make a decision. The null hypothesis is rejected. Step 6, interpret the results. The mean number produced is more than 250 per hour. LO10-8 Compute the probability of a type 2 error. Recall that type I error, or the level of significance, is defined as the probability of rejecting the null hypothesis when it is actually true. It is denoted by the Greek letter alpha. Type 2 error is defined as the probability of accepting the null hypothesis when it is actually false. It is denoted by the Greek letter beta. LO10-8. Type 2 error, example. A manufacturer purchases steel bars to make cotter pins. Past experience indicates that the mean tensile strength of all incoming shipments is 10,000 pounds per square inch and that the standard deviation, sigma, is 400 pounds per square inch. In order to make a decision about incoming shipments of steel bars, the manufacturer set up this rule for the quality control inspector to follow: take a sample of 100 steel bars. At the 0.05 significance level, if the sample mean strength falls between 9,922 pounds per square inch and 10,078 pounds per square inch, accept the lot. Otherwise the lot is to be rejected.